Good morning, dear students. How are you all? So, dear student, this is the second video of class 11, and as we have started the organic chemistry, so we will talk about the tetravalency of carbon. As you know, the electronic configuration of carbon is 2,4, as it has 6 atomic number. So, we will see that here its electronic configuration is written, and we can write also carbon has 6 atomic number. Okay, so carbon is having 2 4 electronic configuration, as you are seeing here. Okay, that 4 electrons it cannot lose or it cannot gain. Have you seen after losing that 4 electron it is forming C4 positive? Have you ever seen? No. If it will gain 4 electron again, it will complete its octet, so C4 negative would be there. It cannot be it cannot do that one, because you know that if it will gain or lose its electron, then it requires very much strong energy, and for that one it does not occupy, it does not arrange that much of energy, and it cannot lose or gain its electron. Okay, now dear student, now you can see here carbon cannot lose 4 electron and also cannot gain 4 electron, but it can mutually it can share its 4 electron. If I will write the electron dot structure, then I will write C. As you know, 4 electron is in their outermost shell, so 1 electron can be written with 1 dot, 2 dot, 3 dot, 4 dot. Okay, now so that 4 electron can be shared with someone. Okay, now dear student, now we will move further. Next, here you can see methane and carbon tetrachloride is there. How methane will form? What is the formula of methane? CH4, and tetrachloride is carbon tetrachloride is CCl4. Okay, so we have to see the structure of this one. The next phase we will talk about that one. Here CH4, the first one was methane, and we can see how it will actually share. As we know that C has 4 electron, 1 2 3 4 electron. Hydrogen as also hydrogen has 1 electron in its valence shell, so you can write nearby to the hydrogen, it will be in front of the carbon electron. Okay, na, towards the side of the carbon, that it can easily share, the carbon will easily share its electron with the hydrogen electron. Okay, na, so after it will share. There is that one. Then it will form single bond. This one will also form single bond, this one will also form single bond, this one will also single bond. So how this structure can look like? CH2 CH3 CH4. Okay, now dear student, so this one is the structure of methane, and here you have understood that carbon can mutually share, okay, na, its electron with hydrogen atom. Now next one we will talk about carbon tetrachloride. CCl Cl Cl Cl. Chlorine has 17 atomic number, and it has 7 valence electrons. So we will write like this one: 2 to 4 to 6 1 7. Carbon already 4 electron, you know. Again this chlorine also have 7 electron, so it will share chlorine 7. You can write 1 only, no problem. Here you can write 2 to 4 to 6 1, that one will share. And how will you write the structure? You can see C Cl 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 Cl. Okay, now dear student, so this was the structure of the carbon tetrachloride and methane. Okay, now the next thing, representation of organic compounds. How can you represent organic compounds? Organic compounds can represent in various ways. First one, you can see complete structural formula. What is the meaning of complete structural formula? If I will take one example of methane, and if I will try to write this organic compound in the structure form. So methane, as you know, it is a CH4. It is CH4. So C, one hydrogen, one hydrogen, one hydrogen, and one hydrogen. What you are seeing? You are seeing that carbon is combining with the hydrogen, and this one is complete structural formula. That carbon is forming a bond with the hydrogen. 4 hydrogen is there, that means 4 bond it has formed. So you can see that this one is a complete structure formula. If I will give another example, then methanol, I will take the example, methanol, okay na? So what is the formula of methanol? CH3OH. How can I write that one? How can I write that one? In complete structure formula, CH3. So all the H will be around to this carbon, but you have to put the oxygen also. As you know, oxygen has 2 bonds. So one oxygen is there, second oxygen, and this one is hydrogen also, because hydrogen has only 1 bond, 1 electron. So it will share with oxygen and leaving 2 lone pair also, because dear student, as you know that oxygen has 8 electron in its valence shell. So 2 to 4, 1, 2, 6, 7, 8. Okay now? So this one is the complete structural formula. Then after, okay, if I will talk about more one more example of that one, that would be easier to understand the next structure formula. So I am writing here C, 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 C. 4 times C I have written. Now I will write hydrogen also. Here I have written hydrogen also. Yes. You can see here 4 carbon is there, 3 to 5 to 7, 3, 10. This one is C4H10. As you have done in class 10, this is the structure of butane. And this one is complete structure. This one is complete structure. This one is not. Complete structure formula, that means it is written with all the hydrogen and carbon is written in the open chain. In the open chains. Here it, second one is condensed structure formula. Third one is bond line structure formula. So we will discuss about the complete structure formula. In the complete structure formula, as I have discussed, that if I am writing CH4, then you can simply discuss, wait, you can simply tell the single bond and double bond in every type of organic compounds by writing the complete structure formula. CH4, how many single bond is there? 4 single bond is there. And if I will give you ethene, C double bond C, okay, 1 hydrogen, 1 hydrogen, 1 hydrogen, 1 hydrogen. Double bond 2, 1 single, 2 single bond, 2, 4 single bond. 4 single bond and 1 double bond. Okay na? So that you can also get the structure from the complete formula, complete structure formula. Now that, then after condensed formula is there. What is condensed formula? After writing the complete structure formula, you have to just shrink, close the chain. Don't write the open chain by showing the carbon and its bond with the hydrogen. Don't show that one, and write in the condensed form. Okay na? So that one would be the condensed formula. I am telling you. Yes, I am giving you the example. Suppose I had written initially about the complete structure formula CHH. This one is complete structure formula, where you are seeing that carbon is forming a bond and shown the bond in the open chain. But what if you have to write the condensed formula, then don't show the bond, but you cannot hide this one. Yes, you can hide also. How can you hide? You can see CS3. How can you write? Not by showing the bond. You can write CS3 single bond, don't write here, and write only CS3. So you can see here is no bond, and I have written the carbon and hydrogen together by counting all the hydrogen. Okay na? So CS3, this one is the condensed formula. Okay na, dear student? Now then after I will take one more example that would be easier. C, I have how many C? You can see, count that. 1, 2, 3, 4, 5, 6. 6 C is there. Okay, hydrogen would be also there. I am not writing hydrogen, but you have to understand that hydrogen is also present. So how many hydrogen? 3 hydrogen, 3 to 5 to 7 to 9 2, 11, 3, 14. So what is that? 2 to 4 to 6, C6H14. As you know, alkane structure, CnH2n plus 2. So this one is alkane. This one is alkane. Yes, we will do that formula, general formula. You have understood that open chain is there. Now I have to write the condensed formula. So condensed formula, how I will write? I will write for the condensed formula, CH3, CH2, 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 1, 2, 3, 4, 5, one more carbon is there. So you have to just write this one. You have to think about this one, terminal carbon, the end carbon. It will contains 3 hydrogen every time. Okay, now, dear student, you have understood? Now we will talk about the bond line formula. The scientists every time actually they are in hurry. They have to write the organic compounds in hurry. Okay, now so they have actually discovered one of the method. They don't want to write that the organic compound with the carbon with the hydrogen every time. So they have discovered this method, and that one is known as bond line formula. And here you can see that this is another way of representing the bond that organic compounds in the zigzag fashion, where the carbon and hydrogen atoms are not shown. Okay, now so if you have to write the structure, then you can see here, if I have CH3, okay, now you have to see that this carbon and this carbon, here one dot is there, here I have taken CH3, this one CH3, simply this one is CH3. Okay, now if I have not shown this one, I am taking one more example. If I have this structure, at the terminal CH3 would be there. Here at every point node, you can say this joint, there is one carbon along with hydrogen would present, but at the terminal position CH3 would be there. So this one is the structure of what? CH3 here, CH2 here, CH2 here. Don't count here in between, no need to count. CH2, CH2. Okay, now so what is the structure of this one? Carbon, 3 carbon, 4, 5, 6. So this one is hexane. As you know, na, hexane, what is the structure? C6 and H14, previous structure. So this you have understood. Bond line, without writing this one, you don't have to write. I had to show, and I had shown that one. Okay, na, dear student, now you have understood. Bond line formula is written for the purpose. Okay, in shorter format you can write. Suppose this one is there. If I have written this one, that means you have to understand here is CH3. Instead, if I have not written this one, this eraser is not working. This, if I have not written anything, here, then you should understand here is methyl group. But if I have written OH, here if I have written CN, then you should know there would be the functional group. If nothing is written, that means CH3. If something is written, that would be the functional group. Then you have to write accordingly that functional group, the structure name. Okay, na, dear student. So we will talk about this this much in this video. Okay, na. We will discuss the next part of that one in the next video. Okay, thank you.